Okay. Good morning, everyone. Good afternoon. I'm Cherry Kubota. I'm a professor at the Ohio State University. Welcome. Welcome to Indoor Ag Science Café, June. I really appreciate your joining today. So this is something we are very excited about, the introducing new technology, science, and information relevant to CEA space. So the idea is supporting CEA industry to move forward. Um, this series of webinars, supported by three groups, funded by USDA NIFA SCRI program, so the Specialty Crop Research Initiative program. One is one is original group at OptimIA group, which primarily focusing on indoor vertical farm. And then advanced CEA and CEA herb groups, focusing on both indoor and greenhouse environment. So occasionally we invite industry speakers and then have them to talk about their technologies, their unique approach of CEA. So today is one of the industry speakers presentation. We have David Ashton from Canopy, located, if I understand, Oregon. Um, and then connecting today to introduce what they do. So the title is Introducing Canopy, How We Got Here and Where We Are Going. Before I show you, actually he's already here. Um, but anyway, so the little bit more upcoming one. So we don't have July cafe. This is kind of traditional schedule. July, we kind of take a break and then usually, intensive conference month for us. So no cafe. And August, we start again with an academic speaker talking about germination technique for herb seeds. And then that particular one is supported by CEA Herb Group. And this today's one, Canopy presentation, David Ashton, supported by Advanced CEA Group, Advancing CEA. So again, thank you, David, for joining that. So I'm gonna stop uh, sharing and then let you share. So if you are, regular member, you probably know how it works, but this part is recorded and then we stop recording so you can ask questions using even microphone. You can use camera. But while David is presenting, please use chat, so that you don't forget your questions. And then we pick up the questions afterwards. All right. With that, David, thank you again. All yours.
All right, thank you. Looking at your prior presentations, I'm gonna have a lot more opinions than the other people, so bear with me while I bombard you guys with my opinions. So I am the founder and CEO of Canopy. We build autonomous greenhouses that help small and mid-sized businesses grow independent of labor, weather, and land. For a one-time fee or for a lease, you can purchase our farms and grow locally independent of major barriers. So this conversation will really focus on what we build, how we got here, and then where we're going. And I'll probably open it up for questions at the end quite a bit. So yeah, I'm the founder and CEO of Canopy. I have an undergraduate from Cal Poly San Luis Obispo in bioresource and agricultural engineering. I graduated in 2016. Out of college, I worked on a hop twining process. So we was approached by a hop merchant. Hop twining is very labor intensive, and so we created a twining method to tie those knots to the top of the wire, so they're about 18 feet off the ground. Now, on my way up to Yakima, Washington, where most hops are grown, the funder of that company filed bankruptcy, so I landed in Oregon because I refused to live in Yakima, Washington. And in Oregon, I found a job in Portland as a mechanical engineering consultant, and there I worked for companies like Meta on their AR/VR systems. I worked for Corning in the Navy with athermalized vision systems, and also places like Lam Research for processing equipment. So I kind of got, to some extent, a really great broad range of mechanical engineering experience. During that time, I worked on this project on the side because I've always been interested in automation for small and mid-sized farms, particularly developing automation that can be leveraged by small and mid-sized people, or small and mid-sized businesses. So in 2021, I started this company. We are now 7 full-time employees. We're currently located in Hubbard, Oregon. No one probably knows where that is. It's about an hour to 45 minutes south of Portland, Oregon. Currently, we've raised about $2.8 million, and we have about $700,000 in grants awarded and pending. Those have been delayed for obvious reasons here with the federal government. So currently, we have a full-scale farm working. The prototype is up and running. It's been running for about a year and a half now. So our focus is to build equipment to empower the next generation of farmers with tomorrow's challenges. We are providing a scalable, standardized greenhouse that really focuses on labor, water, and chemical reduction. So the main focus was to make something that was affordable, and so everything we've done is designed from scratch, really focused on something that would make returns, and we're not using a lot of capital-intensive equipment from off the shelf. Really our goal was to support local food production. So I'll give a brief overview of our farm. So this is our actual farm. This is not a rendering. This farm is about 2,500 square feet. So for an example, a basketball court is over 4,000 square feet. So this can fit within a basketball court. It produces 3 to 4 acres equivalent, or this is about 23,000 pounds of herbs, or about 30,000 pounds of leafy greens. For comparison, the novelty of this farm is not that it produces more product per square foot, it's that it does it completely autonomously. And so when I say completely autonomously, it means that people don't have to go into the greenhouse but once every 2 weeks. So a big aspect of having a farm autonomous for that long is cleaning. The farm is self-cleaning as well. We went vertical not to save land. As a company, we don't believe that land is an issue in the United States. We think that labor is an issue in the United States. So we actually went vertical to simplify robotics. So you'll see in following demo videos that we're actually bringing plants to robots so that we can simplify those robots. We're not using anything really complex to automate this process. So obviously this is relevant to this talk, but it's indoor, so obviously you can grow year round. It's in a greenhouse, so we actually had to design the greenhouse from scratch as well to be able to fit our automation within. So the greenhouse is also our own design. So obviously this is hydroponics because it's vertical, so it's closed loop watering system, reduces water significantly. People don't really enter the farm at all. We've nearly eliminated pesticides. We're using a lot of beneficials in the farm. And then we've eliminated herbicides completely. And lastly, it's easy to use. So we're creating a user interface where you can just essentially select what to grow at the farm. Then you can operate it, and then we'll provide a maintenance service. And so anyone who can really use this farm is the idea. And so this farm is organically certified as well. So this is something we just received recently. This is not an aquaponic farm. This is a hydroponic farm, but it is organically certified. And we also is patent pending, which we should be receiving patents on this farm in the next couple months. So, but the major aspect of this farm is that it is fully autonomous. So that we're not reinventing anything within the greenhouse. We're really copying what's already been proven from a greenhouse growing perspective. What is novel within our farm is the automation. So everything you'll see in this farm has been built from scratch by us and our manufacturing partner. And so, like I mentioned again, this farm is designed to only allow people in the farm once every 2 weeks. And so the greenhouse itself is pretty much closed off to customers that purchase the farm. So right now, our core crops are leafy greens and herbs. We trialed everything from spinach, bok choy, basil, cilantro, and gailon. We're using a modified shallow water culture. So we're not using NFT culture. So we're using a shallow water. So we're essentially filling beds up The water sits in those beds. We drain it and refill it immediately, and so we're able to keep a constant supply. We chose to go this route because if some of the reasons the system fails, water remains within the beds, and so plants will remain alive during that time. So if something fails, because these farms are distributed, we can address those on a. It doesn't have to be immediately addressed, essentially. And then again, like I mentioned, this farm has been organically certified with CCOF. So here's a demo video. Kind of, yeah, go through this. It's probably gonna be choppy since it's through a PowerPoint, but this is our fully autonomous greenhouse. So everything starts with seeding. So here we're using a needle seeder. This isn't anything new. This takes a lot of time, but because there's no trade-offs between each automation system, there's no one standing there and passing them off. We can take our time there. Spends about 10 days in germination and propagation. So we'll use a lazy river. So this allows us to reshuffle plants. For example, if a basil wants to be in there for 2 weeks and a lettuce wants to be in there for 10 weeks, we can reshuffle that. Here, we use transplanting. So this is also a custom designed transplanter. We're picking these up individually. That's because when we implement computer vision, we'll be able to pick up plants based on whether a seed germinated or not. And here we're going to transplant into our plant cups. So you'll see this one robot will place media into these plant cups, and the plants are on a carousel. They rotate around. So there's one location is where we engage our plant bed. We hold the plant bed rigidly, and we can harvest. You'll see this robot. It's very simple. It's just essentially a forklift on the gantry. And so it goes and picks up a plant cup. So this is a unique design because it's robust. The farm can pick up plants independent of their characteristics because we're actually interacting with the plant cup. We're not ever interacting with the plant. So this could be a head of basil. It could be a butter lettuce. It could be a salad mix. We can grab it independent of the plant characteristics. Then we'll harvest here with a cutter. And so a big aspect of having a autonomous farm is self-cleaning, like I mentioned. So you'll see after every harvest, the plant cup opens, it drops the media out, it recloses the plant cup and places the plant cup back into its original position. So this allows us to reduce one-time use plastic significantly. There are a couple steps that aren't shown in this demo video. One is there's a media magazine that holds media trays, about 2 weeks worth. So that's going to be refilled every 2 weeks. And then another process that's not shown is after this harvesting robot opens the plant cup, drops the roots of media, it brings it over to another station where it cleans the plant cup with high pressure steam and zero tall. So after every use, the plant cups are not only cleaned of debris, but also sanitized. And then lastly, we have a watering. I didn't show watering here either, but we're essentially lifting beds up at an angle. The water pours off, and then we refill it. And so we experimented a lot with the watering techniques. A lot of times we drain from the bottom initially, and we realized that all the gunk and debris on top of the water just lowers. And when you refill, it just goes back to the top. So by tipping the bed, we're actually having water flow off the top of the bed. So it actually clears out the debris a little better. Here we go. So going back a step, so after introducing the farm, we're acknowledging many problems. I think everyone is aware of what's going on with food system in the United States. But we have a different perspective. We think that the United States has a nutrient problem. We don't think the United States has a calorie problem. And so people ask, why aren't we growing things of higher calories? We want to grow things with high nutrients because the United States has plenty of calories, but most Americans are nutrient deficient. And like I said before, we believe the United States does not have a land problem. There's plenty of land in the United States. We have some of the most land in the world, but our labor, we have significant labor shortages. So you see here below, we're importing more leafy greens and herbs than ever from Mexico. And we believe that's being driven mostly from the cost of labor. So you can see specialty crops, the labor accounts for 40% of all farm costs, and the next being livestock. So significant costs in labor for specialty crops like berries, fruits, vegetables, and nursery crops. And so we're kind of late to this game. We've been able to see what's been going on in the industry for quite some time now, almost a decade since some of the first investments went into these three categories of CEA. We've broken it into vertical, indoor, greenhouse, container. There's a fourth category of like other, which is things like in-farm and Babylon, which is more like at least micro farms within stores or people's houses. But these are really the ones that we were focusing on because they're high production. So vertical indoor farms, uh, we believe that these are very expensive automation. A lot of times, these farms. If you've seen videos, they look like wafer manufacturing facilities, and we didn't think that there was a need to go that expensive with the facility because at the end of the day, we're just growing lettuce. Obviously, with indoor vertical farms, the energy costs are very high, so your costs are directly tied with the energy costs. And additionally, these farms are centralized, and so you have to go through distribution to be able to sell the amount of product coming out of these farms. Greenhouses, everyone knows our greenhouses. These are natural sunlight, and they've been proven to be financially viable. But the issue with these is that they're still centrally located, and so they still need distribution. And kind of taking a step back, the picture in the back is Salinas, California, and I think a lot of the waste and cost that comes out of traditional agriculture is because of centralized production. And so it was interesting to see vertical indoor farms and greenhouses growing so much in one area where they still require that distribution. Whereas container farms, they took a different approach where they weren't centralized; they could be distributed. But the price per pound of products is the highest of any other farm because there's no automation really in terms of harvesting and transplanting and seeding. There's a lot of LEDs requirements. You're required to have LEDs. And then lastly, containers are just not designed to grow produce. And so they have to be heavily modified to actually be able to grow produce efficiently. But the benefit of containers we saw was their ability to bypass distribution and address niche markets. And so our positioning here is we focus on two main axes. One is lower cost of production, so energy, labor, land, really the three major input costs, and then supply chain independence. So you can see we broken out the companies in the landscape, whereas companies like Earthbound Farms and Taylor Farms are extremely difficult to compete with because their cost of production is far lower than anyone in CEA. But their one drawback is they're always going to be tied to supply chain. They always need to go through the cold supply chain through distribution. They always need to package, and so those are the chinks in the armor, I guess, of large scale ag to some extent. So the learnings from the industry, to sum it up, as Canopy has been able to observe is that we need to focus on farming, or in other words, focus on margins. It'd be nearly impossible to pay off a $200 million facility with lettuce. And so we need to really focus on how do we reduce the costs significantly with our CapEx costs with our farm. So the answer to that was to build it all from scratch ourselves and really focus on cost reduction at all cost. We also want to focus on offtake. So being able to sell the product comes out of the farm is very difficult to go from zero to a 20-acre greenhouse of selling product or a significant amount of produce from vertical farm. So we want to build incrementally to demands, not build and then try to create demand. Then also, we didn't want to do too much, so we had to pick a lane. So I think it's very difficult for a company to not only build farms, grow produce, distribute produce, but also to market produce. Those are all individual companies by themselves. I think that is very difficult to be successful when you're taking on that much responsibility within the food supply chain. I think that's why so much money was required to demonstrate these concepts. So for us, we're just building farms and selling the product and selling the farm itself. And so we're not in the business of manufacturing. We're not growing. We plan not to grow produce in the long term. We don't plan to distributing or marketing the produce in our farm. So we focus on just developing the product, which is our farm. And then we've also learned that produce is very relationship driven. And so instead of trying to create brands and compete with large scale brands, we can leverage existing local brands that are very strong because people care about supplying. People care about buying local because it supports local businesses. And then lastly, we had to focus on selling equipment and software because to get funding for CEA is very capital intensive. So we have to acknowledge that we would have to essentially raise venture capital. And so lettuce sales is very difficult to provide returns that venture demands. Then lastly, to kind of sum all this up, sum all this up, is extremely difficult for CEA to compete with big ag on price and marketing in the identical markets. And that's a key focus of ours, is that at the end of the day, the competition isn't all within CEA, is with large scale agriculture as well. So if you're going through the exact same distribution, you're finding yourselves on the same shelves as large scale ag, and your biggest differentiator is is um is branding or the quality. It's very difficult because people mostly buy produce based on cost, and they look into the container and they can see the quality. So there's not a huge obvious quality difference. Is very difficult to compete there. And so that's kind of a little background of what's got us started. But the actual how we got this started was I wrote about a 50-page business uh, plan when I was working full time. And so all these things I was observing and taking notes on that I've been describing. And then my next step was to find a co-founder. So I'm a mechanical engineer, and I need to find someone that was a software and electrical engineer. So I wrote this business plan not only to recruit my co-founder, but also to prove out that this concept works myself. There's billions of dollars spent on CEA, and I was like, okay, I have an idea. I need to prove it to myself before I quit my job. So here's kind of half of the business plan, but I designed the whole farm from scratch by myself at night. It took about 3 years, and I really want to prove it to myself that this concept makes sense before kind of jumping in full steam ahead. So I also did a pretty significant competitive analysis here. I don't need to go into this in detail, but kind of shows the work I put that was needed to put in before going in to apply for grants, which was how we started this company. And so I got after recruiting a co-founder, our first major milestone was receiving a National Science Foundation Phase 1 grant through the Environmental Technologies cohort. So it's just me and one other person. We got about $250,000 grant, and we wanted to prove the automation out in a warehouse in Portland. And so here's our first prototype. You can see in this picture. This farm does everything from media magazine to seeding to transplanting to harvesting to sorting into bins. And so this was a subscale prototype that we proved out. We use this to raise additional capital to get us to the bridge round. And then our next major milestone was getting a Phase 2, which is about $1 million. And this was used to build a full scale farm, which we saw in previous videos. From there, we were successful building that farm with $1 million. We added one extra person. So with 3 people, we built that entire farm you guys saw there. It was a lot of work, but I think it kind of speaks to itself that 3 people were able to design and build that. So it kind of speaks to simplicity and effectiveness of that farm. From there, we got an NSF seed extension. So that was about $200,000 to get organic certification for our farm, and then also start collecting proof of concept data. And lastly, we've applied to a Phase 2B. We've been awarded this Phase 2B, but it's currently pending as there's been a lot of delays in the federal government. But this grant will focus on preparing our farm for mass production and enhancing software systems. So major challenges early on have been finding capital, not only finding capital, but finding patient capital. And so we were pretty lucky to be in Oregon. All of our investments have come through Oregon firms. So NAMI, Virtue Labs, Willamette Valley Capital, TIE is an angel group, Elevate Capital, and Ideaship. These are all Oregon-based investment firms. And Oregon's unique in the sense that a lot of the money from these firms were coming not from limited partners who are high net worth individuals, but actually taxpayers. So Oregon has incentives to essentially give taxpayer money to venture capital firms to invest into Oregon companies. And so with that, it's a little more patient capital than you would get from limited partners who really demand those returns quickly. Then obviously we've raised a lot of money from the National Science Foundation. Business Oregon does a matching grant for SBIR grants. Then also we were just awarded a USDA Phase 1, so we can kind of restart this process over again with the USDA. And so along this way, we've created lots of partnerships. As I mentioned before, our company Canopy will only really focus on R&D and training. So always be introducing new crops, always making new adjustments and honing our technology. then also training individuals to maintain these farms with a like a spoke and wheel type model. We've been fortunate enough to create a partnership with manufacturer GK Machine. As you can see in this picture, this is their new $200 million manufacturing facility. They're one of the largest uh, agriculture equipment manufacturers on the West Coast. And so we designed our farm around their capabilities, which has allowed us to make the farm more cost effective. And so everything in our farm is essentially designed around what their processes are, and we'll be able to make these farms about one every 2 weeks. And so our farms are standardized like cars because we want to be able to mass produce them and have inventory before sales so we can scale as quickly as possible. And then when installation and construction, we're working with Essex Construction, who are known for building a lot of uh, fast food restaurants within Oregon. And so they have a really great knowledge and be able to bring out the utilities, get the zoning for relatively small footprint buildings. With our market currently, we have a pilot agreement signed with Ratto Farms. They're about down the road from us. So Ratto Farms has really helped us learn about growing produce. As raw engineers, we focus on the automation side. He was instrumental to helping us understand growing basil organically, hydroponically. So he's right now we're collecting proof of concept data to have an initial sale with Ratto Farms. We also submitted a USDA grant with the Northwest Transplants. So this grant will focus on living basil harvesting or living crop harvesting. I'll talk about that in a little bit. We think there's a pretty strong market there as well. OSU has submitted an AFRI grant. It is submitting an AFRI grant once the RFA is released by the USDA to build 2 additional farms on their campus. Then our current farm will transition to selling produce to GK Machine at their campus dining once their facility is completely constructed. It also had a lot of interest from Market of Choice, which is a local supermarket, high end, more so like Whole Foods, that's located in Oregon. It's a family owned. We have a lot of different folks in our pipeline as well. As I mentioned, we plan to sell these farms to customers, and a big part of our farm's ability to be autonomous, it enables us to address additional markets. So when talking to these different types of companies, they want nothing to do with being farmers. They want no paradigm shift at all. Currently, for example, Market of Choice, their workers come out of their central kitchen, they go into a truck, they grab a bin of lettuce out, they bring it in, and they put it on the shelves. They want almost no paradigm shift from that. So with our farms being built on site, workers can walk into our extension building on our farm. They can grab a bin of produce and they can bring it in. There's no paradigm shift there at all. So we'll essentially become the on-site wholesaler for those companies. And so we've seen a lot more traction from non-farmers because of this hands-off feature of our farm. So we've had interest from Mountain Rose Herbs, which is their CEO is visiting, and they have a dried herb wholesaler, one of the largest in the country. Burgerville is a local fast food chain. Oregon Department of Corrections, they run a lot of the prison system in Oregon, and they're visiting tomorrow. Catlin Gable is a private K through 12 school. It has about 800 students. They have their own dining service within the school. Wild Host Casino is a Native American tribe in Eastern Oregon, which they don't have access to really ability to grow food. There's a very little arable land in Eastern Oregon, which is high desert. The Ground is a farm and event center, which is a farm that sells a lot of produce to restaurants, high-end restaurants, and also has a farm-to-table event area. To mention GK Machine, the cafeteria, and then additionally Kramer Farms, which is a nursery in Oregon. They don't actually sell edible food, but because it's been very difficult within agriculture in Oregon, they're looking to diversify. So this is a good example of the farmers who are maybe dairies or maybe they're growing fuel crops. They can also buy a farm and have a baseline complementary production of leaf greens and herbs. And so we see a pretty significant opportunity outside of farmers. And as I mentioned earlier, it's very difficult to compete in larger markets against a large scale agriculture. But we believe we can compete through vertical integration. There's been a lot of success with Kirkland brand, so Costco's Kirkland brand, with vertically integrating product because it improves margins of up to 40%. but it also eliminates cold supply chain completely, which there's a lot of interest in being more sustainable. But the biggest point here is that it removes self competition. So if a company like Market Choice or a company or a university like Oregon State University buys our farm, puts it on campus, they have an incentive now to sell produce from the farm. So that removes shelf competition completely. This is a significant competitive advantage that we believe is our way to enter larger markets. And so these markets are significant. So hospitality sells about 2 billion pounds of leafy greens and herbs per year. Supermarkets sell 3 billion pounds of leafy greens and herbs per year. And campus dining sells 150 million leafy greens and herbs per year. And our farm, for comparison, grows about 30,000 pounds of leafy greens and herbs per year. So pretty much limitless building potential for infrastructure within these different markets. So looking ahead, as I kind of wrap this up a little bit, we're currently being written into an OSU research to focus on local food systems resilience by and comparisons with supply chains and mitigating workforce shortages. So there's two aspects of this grant that's being submitted. We want to focus on Asian crops and varieties in the U.S. markets. Right now, there's a lot of monocropping in the United States, so it's very difficult to introduce new varieties. I think something that's pretty interesting is that the United States has essentially leafy greens, like salad mixes, as majority of Americans eat. But in China, they eat, I think, over 60 different varieties of leafy greens and herbs. And so its research will be focusing on looking at different Asian aerials that might have some market demands that we can be scaled incrementally with our relatively small farms. Additional research will be on picking and pruning automation from researchers on robotics within OSU. So once the grant progresses into year 3 or 4, we hope to be able to introduce vine red produce and use the picking automation to do that. I think our farm is very well suited for picking automation, mainly because picking automation is very difficult in fields, because usually if you're having robotics applied to your business, you have a significant acreage. And so if you go through and you miss a crop, for example, picking a tomato or strawberry, if your robot misses that, that's spoilage because you're not coming back around to pick that crop. With our farm, crops pass robots multiple times a day. And so this allows you to have a more efficient picking success, even if it isn't as successful, if that makes sense, because you'll have multiple opportunities to grab that crop throughout the day. And so the collaborators on this grant are Oregon State, Chemecum Community College, and then also Michigan State University. We've also received a USDA Phase 1. So this will focus on robotic harvesting and packaging of living crop varieties. So this was a grant submitted with the local farmers. We believe that living crops, so if you go to the store, I'm not sure, it depends on where you're located, but if you go to like a Trader Joe's, there's basil that have roots on it still, and the crop is still alive, so it reduces waste and it keeps the product fresher. We believe this market has significant potential for local farmers because this packing efficiency is so bad that it doesn't make sense for a larger scale ag to address those markets because you can't really ship air around. It's very cost ineffective to ship air, and so providing local living crop capabilities within our farm will allow us to address markets that large scale agriculture doesn't make a lot of sense to address. So next year we plan on building 3 pilot farms, one with food service, one with campus dining, and one with farmers. So we kind of want to prove out our technology in 3 different markets. Additionally, we'll be raising a smaller seed round, about $3 to $4 million, to implement computer vision for decision making within our farm. So currently, everything's really based on timing in our prototype. So plants harvested, right after it's harvested, it's transplanted. Right after it's transplanted, we seed more. But we want to implement computer vision, so we're able to make harvesting and transplanting decisions based on computer vision. Additionally, we would like to implement crop monitoring services so we can look at our canopy and assess plant quality and adjust nutrients and airflow accordingly. And so our farm, as you saw, is also pretty unique in the sense that we can essentially have two cameras in the farm on our gantries, and with those two cameras, we can see every single crop in its life cycle at any given time, which is a very cost-effective way to use very expensive vision systems within CEA. So again, the ability to move our plants around in a vertical carousel enables us to really reduce the cost of equipment in the long run. Yeah, so that's all. I think kind of left a lot of time for questions here.
Okay. Well, thank you so much for sharing. It's interesting. I really appreciate.